Welcome everyone. In this video, we're going to learn how to use this formula to integrate. Now this is a simpler version of the formula f times g, where f is representing u and v is representing g, another function. This is the simpler version of the integration by parts formula. There might be other formulas you have seen just in different notation, but this is eventually the easier one to remember. So I'm going to go and show you how to use this. So if you're integrating this piece right here, you're making a selection of two pieces. You're selecting u, and eventually when you take its derivative, you get du. And then you're also going to select dv, so that when you take its integral, you get v. So that everything right here is going to be followed by this formula. Whatever the result is, we're going to do u times v and then minus v du. So we're always selecting u and dv in this formula, so that way we know how to integrate this. So as it is written here. Let's go ahead and try to do an example. So let me give you an example. Say you want to find the integral of the functions, say x times e to the negative 3x dx. So you see you have product of two functions. Here is x, here is e to the negative 3x. So we're going to go ahead and integrate this by using this formula. So we're going to select two things, u, and I'm going to write like this, dv. And with that, you're going to recover v by integrating dv, and you're going to get du by differentiating u. So let's go ahead and do that. So it looks like we can select u to be the linear function, which is x. That means this remaining piece has to be dv. So I'm selecting this to be u, and then this piece to be dv. So dv is going to be e to the negative 3x dx. Now u is x, so that means its derivative, it's going to be just 1, and we tag along dx. Now to get v, well, we need to integrate this. So you're integrating e to the negative 3x dx to get v. So we're going upward. Now, if you integrate this, you're going to get e to the negative 3x divided by 3. I'm going to hold on to plus c, because at the end, once you integrate this whole thing, you're going to get another constant. So we'll tag along plus c at the end. So let's write this as negative 1/3 e to the negative 3x. All right, so now we use this formula above. Now here's a quick way you can remember that. You simply draw a line here, u times v, and then draw a line this way. So it looks like a 7, but that's how I like to remember this. So u times v, that'll be this right here, and then v du will be this one right here. So hopefully you see that. So let's go ahead and set it up. So we're integrating this function, x e to the negative 3x dx, and this is equal to u times v, that's x times negative 1/3, so I'll put it right here, e to the negative 3x, that's u times v, minus the integral of v, so that's this right here, that's negative 1/3 e to the negative 3x times du, that's right there, that's just 1 dx, so dx. Now let's simplify this, and then we integrate the second part. So this is simply negative 1/3 x e to the negative 3x plus 1/3 the integral of e to the negative 3x dx. So here I just push this outside the integration sign. And keep on going. This is negative 1/3 x e to the negative 3x. Now we integrate this. So this we know from before. It will be, so I have positive 1/3 times e to the negative 3x divided by negative 3. And now we can bring our integration constant since we finished integrating. So all of this is equal to simply negative 1/3 x e to the negative 3x. And then here, these constants, you can combine them, multiply them. So this is negative 1/9 e to the negative 3x plus the constant c. So that's the answer to this integral right here. And we have done that by simply using integration by parts. Let's go ahead and try to use this formula for another example. Here again, I have product of two functions, and it looks like we can use this formula again. So we have to be very careful with what we select our u and dv to be. So now just by looking at this format, I'm just going to rearrange the terms. So you can write the ln of x first, and then x dx. So the reason I do that because I want to pick this to be u and this to be dv. And the reason I do that, you will see why, because you'll see later the formula will work out very nice. If you select u to be dv, sorry, u to be ln of x instead of x. So check that out. So I have u to be ln of x, and I'm choosing dv to be the remaining piece of it. So then I can get du by differentiating u. Now you see why, because I know the derivative of ln, but I haven't learned how to integrate ln. So it wouldn't make sense to pick this to be ln because you would be stuck. So hopefully you see that. The derivative of ln of x is simply 1 over x dx. And then v, well, I know v is going to be the integral of this, and that's also power rule, so we know that. So we know that v is the integral of x dx. So that's going to be 1/2 x squared. So now I like to draw this line like that, and this is the formula. So this integral that we're given, x ln of x dx, this is equal to u times v. So here you multiply these. So that's u times v. That will be 1/2 x squared ln of x. And then you integrate these guys right here. So this is minus the integral of v du. So that's 1/2 x squared 1 over x dx. I hope you see that. That's the formula we have right up here. Okay, so now these integrals are pretty straightforward. So let's carry on. So this is 1/2 the integral x squared over x, that's just x dx. And rewrite the terms before. This is x squared ln of x. Now we know how to integrate this. That's simply power rule. So this is equal to 1/2 x squared ln of x from before minus 1/2 x squared over 2 plus the constant c. And we combine 1/2 and the 2 on the bottom. So 1/2 x squared ln of x minus 1/4 x squared plus the constant c. So that is our answer to this integral right here. Sometimes you have to be very selective with what you choose u and dv to be, because dv, you want to choose something that you know how to integrate, because that's how you get v. And you can be flexible with that, because u is differentiation when we have learned enough differentiation to get du. But very careful what you choose dv to be. That should be something you know how to integrate. All right, so this is it. I hope these two examples helped you to understand integration by parts a little.